Can programming be liberated? I love that word, liberated. I think that we should use that a lot more in programming. By functional style, though, he doesn't really mean functional programming, like you think about it. And the truth is, that's not what we're going to talk about today anyway. By von Neumann style, he means Algol and Fortran, the languages that he helped build. This was his apology for inventing Fortran. Yes. Today, he would mean C. He means having some big mutable state that you kind of go step by step by step, and you change and change and change, and for loops and while loops and things like that. Mutable state. What he was trying to talk about, though, and what I found the most interesting, and what I want to talk to you about today, was this thing, algebra of programs. So the idea is that you can take complicated things, break them down into smaller things, make those smaller things very generic, very simple, and then put them back together. And that's what algebra means. Algebras are rules for breaking things apart, transforming them, and putting them back together. So let's talk about that. Now, I want to be clear. I am not having a functional programming talk. Swift is not a functional programming language. When you try to make it a functional programming language, bad things happen. Mostly your head hurts. We're not going to talk about immutable data structures. We're not going to talk about recursion, monads, or any of the rest. We're going to talk about algebra. We're going to talk about composition. Building things up out of existing reusable parts is better than building one enormous, complex piece of software every time you have a new problem. There's obviously the benefit of code reuse, that you could use, that piece again, but also just understanding it. There are ways that we can think about small pieces of code that are very difficult to do for enormous pieces of code. So we can reason about it. Now, I would say most people agree with that. I haven't said anything controversial, right? In 1977, everyone agreed with it too. There was nothing controversial. So what's the point? I mean, go back. So what's the point? I mean, we've learned our lessons. We no longer build these big, enormous, all interconnected, monstrosities like in the Fortran days. We've learned our lesson. We would never do that, build one massive thing. Our classes are simple. They do one thing. They do it well. No, Rob. I mean, come on. My view controller is composed of search results updating and search controller delegatingness and search bar delegate and my view. It's made up of all these parts. No. An object that conforms to a whole bunch of unrelated protocols is not composition. It's the opposite of composition. You have taken things that someone made different protocols for. They intentionally split it up, and you smash them together into one big object. That's not putting things together in little pieces. How does this look in code? What do I mean? I see code like this all the time. Maybe you have, two different states in your view controller. You have I'm logged in, so I want to get all my messages, my Instabook tweets, or whatever we would call them. But I also have this other state where I'm not logged in, and I just want one cell that says log in. And so in all of my methods, I have a little check. If I'm logged in, do one thing. If I'm not, do the other. It's not so bad. And then you add another state. Maybe I have a searching state. And now I have, two ifs. It's not too bad. And then they call you up. And they go, hey, here's what I want. I want that users who have never logged in, they should get some kind of default content to kind of get them started. But if they had trouble logging in, of course they should get an error. But if you pulled a refresh, then it should give you, all of the some kind of refresh or cache data, and and that's when you go through the 7 stages of developing a new feature in this code base. There has to be a better way. What if we use composition? I mean actual composition. What would it even look like? Funny fact, there is no rule that says that a data source has to be a view controller. Now, a data source, like a table view data source or a collection view, they do have to be NS objects. It's sad, but true. But they don't have to be view controllers. You can make an object that does nothing but be a data source. Well, if you have that be true, then I could make one data source that just handles my browsing state, and one data source that just handles my searching state, and one that handles just my login state. I can have for all of my states a data source that does nothing but handle that state. And then all I have to do in my view controller is swap them out when I switch states. Now the ifs kind of go away. Now the ifs don't completely go away. They can't go all the way away. They have to be somewhere. The if logic, all the crazy if, then, else, and everything, that is the magical rainbows of your unicorn app. I mean, your app does weird things, I promise you, because you have users. And users are weird. And they want weird things. So the weirdness has to live somewhere. But it could live in one place, the one place where I switch my data sources. Everything else gets to be simple. Now, I've broken it up, but now I just want to think about the first two, the browsing and the searching. And, kind of they're the same thing. There's a lot in common. I mean, really, searching is just browsing with a filter. Actually, if you think about it, browsing is just searching with like a filter that says show everything, right? They're actually almost exactly the same thing. It's just what's your filter? Well, once I realize that, I can make an even simpler data source or a more powerful one and reuse it, maybe a fetch request or a network request or whatever you want that handles all the cases, and you could hand it the filter. And that gets kind of exciting. But then you think about your real code. You think about your cell for index path. And your cell for index path probably looks like this. Cell for row at index path. You pull it out, you pull out your cell, and then you start pulling things out of your model and plugging them into all the parts of the cell. And the trouble is, if you have all these different data sources, how does this method work? And that's really hard. That's really hard. It's really hard because this is wrong. This is missing the point of model view controller, of MVC. Most apps I run into, they seem to basically get the idea of model view controller, the idea, and even if you use other things, Viper or whatever, the rest, they all are really just fancier versions of model view controller, where you have this idea that you have a controller that coordinates between models and views. I really, really mean it. It just coordinates between models and views. That does not mean that your controllers reach into your models and rip out all the pieces and then stuff them into views. They just get models and views together. All it should do. Let's think about a very, very simple model and view. A label, UI label. The model object, it's a view. The model object for it is a string. Now, when you want to put a string into a label, do you tear all the parts out of the string, take each character out, transform it into a glyph, figure out where it goes in the string, in the cell, and then plug it in? Of course not. You just hand it the model. You say, label, you know how to display strings with fonts and wrapping and all. That's your problem. Have your model object. Well, why does that go out of our minds? Why do we forget that when the model object is complicated? And you have a person cell and a person. Just give the person to the person cell. Let it deal with layout. Now, if we do that, all of this code turns into this code. Now we just pull out the right model object and hand it to the right view. Well, that was the job of the data source, or of the view controller. Well, that's kind of cool. That feels like it could be generic. I could just turn that into a protocol. And now I have something I could use for anything. And this now can be all kinds of, using this kind of thing, I could come up with all kinds of different data sources. That could be very powerful. The same idea works for login data source. As I said, it is just a data source that hands you back the same cell. It always hands you back the please log in cell. Well, we could make that generic. That's a static cell. It's a one-time cell. Maybe I hand it a cell when I create it, and I just say, always give it back to me. Same thing. I could then build complicated ones. I could have data sources that make network requests, or do core data requests, or whatever. The beauty is, while a network request data source is going to be complicated, because networking is complicated. It's complicated in one place. And that's what we want. New example. This is a question. I'm on Stack Overflow quite a lot. This is a question I get on Stack Overflow all the time. They ask, so I have this list of names and this list of ages, and I want to sort them together so that the order of the names and the order of the ages matches up. And there's always someone who helpfully comes in and says, oh, this is so simple. This is simple. You just zip them together, sort them, and then unzip them. And, well, there's no unzip in Swift, so, OK, here's a little code to do the unzip. And they go, oh, yeah, that's easy. OK, easy. But, I mean, it's not that bad. I guess you could copy it. You'll copy it in, slap it in your program. But then, what happens next? I want to add user IDs. So I now have 3 things. So now I have to zip 3 ways. Oh, and then I add managers. So now I have 4 things. I have to zip 4 ways. And oh, I want to do insertion. So I have to remember how to insert into all of them at the same way. And then I want to move. And I have to figure out how to move them all together. And you finally get it working. You finally get it working. And then your manager calls you up. Hey, how about if we sorted by manager first and then by name? Better way, better way. What can we do? We can turn this inside out. So instead of having 3 different arrays that live in one struct, or in this case, 2 different arrays that live in one, or excuse me, yeah, 2 different arrays that live in one struct, I have one struct that lives in an array, and that struct has 2 properties. So instead of having a name array and an age array, I have one person struct, and then I just have an array of them. Well, now sorting is easy, but everything becomes easy. When I add an additional field, it's still easy, right? It doesn't change any of my other code. I can change my mind on sort orders. I can do all of those things, and it's impossible for it to be wrong, right? I can't mess it up because the compiler wouldn't even let me. I can't get them out of order. What would happen if your name array and your age array were different lengths? I mean, it's like, that should never happen. That's illegal. Well, you need to check that it didn't really happen, because it can happen. But here it's impossible. There is no way a person doesn't have an age. It cannot happen. That's what I like to see. We call this, what I've done is I've turned it inside out, right? And what we call that is a dual. A dual is when you do that, when you look at a data structure a different way. And it lets you think about it to solve other problems. You can do all the same things. 3 arrays of 1 item each, and 1 array that takes a struct. Every problem you can solve with both of those. But some problems are easier to solve one way or the other. Let's think about another one. I often see this. I have one class here, and it has a name optional, an age optional, city optional. But do I really have a world where you could have a city but no age, or a city but no name? I mean, almost certainly all of those. I need all of them. Or I should have none of them. Well, but this way it's possible to have any mix match I could have. How do I fix it? I turn it inside out. I hoist it into a type. Now I have all the data or none of it. It's still OK that the person is optional. And again, I went from 3 optionals to to one optional. What is this about? This is a type. And what is a type? Let's think about a diagram or all of the possible values that your variable could hold. I mean, it's not every variable that exists. It's some group of variables. Say I'm thinking about an integer. There are 2 to the 64th possible integers. Other things are not integers. Strings are not integers. So that's the type. It's kind of a named subset of all of those values, together with a little bit of context of what do they mean. Then I want you to think about what type or what values make sense in my program versus what values are legal. So think about your current state. Maybe you have a loading state, a viewing state, an editing state, and you're representing that as an integer, 0, 1, 2. Well, an integer can hold 2 to the 64, something like a quintillion values, and you're using 3 of them. That's a lot of waste, but it's weak. We call that a weak type. If you're using a string, so there's not a word for all the number of possible strings, but it is finite. There actually are only so many strings that can exist because you'll run out of memory. It's a big number, but it's not infinite, and it's not every possible value. Not all things are strings. But if you're only holding, say, 20 keys, so you have keys that are strings, and only 20 of them make sense, that's a very, very weak string. Now, or use. Now, that doesn't mean that strings are weak. Strings can be strong. If what you're holding in that variable is something I pulled off of a web page, well, literally any string that could exist could have been on that web page. Therefore, that's the correct type. It's what you mean. Say what you mean. So how do we fix this? How do we make a weak type strong? The answer is we shrink it. We give it fewer values. If we're perfect, we give it exactly the same number of values as are legal in my program. So that the only things this program can express are things I want it to express, or else the compiler won't help me or won't do anything. When you have stronger types, when you have stronger types, you get rid of illegal values, illegal states. Every time you have an illegal state or an illegal value, you have to write a test to make sure it never happens. When you have a type that can't be wrong, you don't have to write a test. It wouldn't compile. The compiler is your test. Makes whole classes of bug impossible. That's what I like to hear. I like to hear this bug cannot happen, rather than I tested a lot and found that it did not happen. I would rather something that was so simple and so type constrained that there's no room for a bug. So what does this really mean? What does this mean in practice? It means that we need to look at our squishy types and make them stronger. Let's look at the squishiest type, the softest, weakest type. Almost. There are a group of types that all have weak in their, have unsafe in their name, that we could have an interesting discussion over beer as to whether they are weaker than any. But for regular use, the weakest type is any and any object, which are almost the same. They can hold anything. Does your program really have places in it where you could take, anything at all, absolutely anything, any string, any integer, a person, a UI view, a view controller, a Bluetooth peripheral? You do not care. You will accept it. That doesn't come up very much. One famous case, it comes up in print. Print does, in fact, take an any, and it means it. Anything you pass to print, it will generate output for it. But I have rarely had a case where I had something that I don't care what you give me. You usually care. Now, I know that any shows up in JSON parsing, or at least it used to. It's not so bad anymore now that we have Codable. But if you are running into these, usually because of Cocoa still, you can still put a box around them, hoist them up into a real type, into an enum or something else, and get the any's out of your program. So many questions, so many bugs happen with any. It will break your program. The only thing that will break your program worse than any is optional any. Once you have optional any, just start drinking. Second most misused case, and this is probably the most abused type in all of Swift, is dictionary. Dictionaries are arbitrary mappings of keys to values. Means any key value pair should be okay, should make sense. I have this kind of thing. I have a dictionary where the first key is name, the second key is title. Would I, maybe the next key is the entire text of the newspaper. No. The key is not the entire. We know the next key is something like maybe phone number, right? There's only a handful of keys that could be next because this is not arbitrary. These are very, very specific. They're so specific that we should just call them out. This is a struct. Make it a struct. Don't use a dictionary. Stronger type. This business of using strings this way actually leads to this idea called stringly typing, which it turns out, I thought that this was a problem in like the Swift world. I found out, I started to do some research, every language in existence has this same problem. Everyone does it. Okay, let's think about cases like this. I have, case start, case end, and so there's two different kinds here. Well, and you go, oh, no, this is fine. I know I should put constants here. I'll put string constants here. That solves nothing. That is nothing. The problem is not the fact that there's a string here. The problem is that there's fatal error. Why would you? I hate every time I have to write fatal error. It means something has gone wrong. I mean, I've had to go in and write a line of code that I hope never crashes or never runs. The problem was we didn't really have strings. We had tokens. We had specific values. One or the other. That's an enum. Use an enum. And you go, but Rob, I need the string. I still need the string. That's okay. That's okay. You can turn them into strings. It's fine. But it still is a strong type. How about lowly little int? I mean, int, okay. Yes, ints are sometimes used as when an enum should be used. But I actually find people usually get that right. People don't have too much trouble. So I'm not worried about that. But what if there isn't a small list of possible integers that are valid? Like literally any integer would be valid. Like let's think of an identifier, right? This little structure, by the way, slightly bigger version of this. This is the structure that was in my code that caused me to write this entire talk. We had one of these, and we had this ID that was an int. But is an ID really an int? Is an identifier number an int? Can you add two of them? Could you multiply two identifiers together and get a sensible answer? Well, no, but integers you can. So you have something other than an integer. In fact, you don't even really have a number. You have an identifier. Well, call it an identifier. Let it be what it is. Lift it into its own type. In Swift, this is free, by the way. This takes no extra storage. In fact, int itself is a struct in Swift. Crazy but true. Now, I can't accidentally add to identifiers. And because I've nested it, I have a person ID. Maybe I could also have a message ID. And the compiler will stop me from passing a message ID when I mean a person ID. Also, and this was the trouble that I ran into, what if you change your mind on what you're going to store it as? You decide they really need to be strings instead of ints. Maybe because they've gotten really long, they're too big, they'd actually overflow an int. Or you need hyphens or whatever you want. Well, you have to go through your entire program and consider every int and go, is this int actually an identifier or is it really an int? And that is really obnoxious. But here, you put it in one place. This is a pretty common API that I've seen in a whole lot of different versions of it. And sometimes it happens because Cocoa does things this way, but we can do better than Cocoa. So we have this login, and it has a username and password, and then it has some completion handler that's going to hand you back maybe a string and maybe an error, a token, I guess, because you can see down here that So it should be a token. It's going to hand me a token or an error. So what's wrong with it? Well, the first problem is this completion, the completion block, where I said string. Well, what does that string mean? I mean, when I'm looking at this block of code, what does that string represent? It's a token. I just told you it's a token. But I just had to tell you, you don't see it anywhere in the code. Now, I could go in, and Swift allows me to add these little labels. This label is useless. This label is a comment. It has no impact on the compiler whatsoever. It is not part of the type. So if somebody else had, stuck some other something else there, the compiler won't tell you. So that doesn't really help us a lot. I mean, you might as well put a comment. And also, you can get a lot of things that aren't tokens might wind up in this string, right? Have you ever had the case where you have a string, and instead of having, John, it has optional parenthesis quote or backslash quote John backslash quote, because you accidentally took an optional and stringified it. Happens all the time because they're not strong types. Anything can be turned into a string. So strings are really, really sloppy. Because I don't mean a string. I mean a token. We lift it into a token. Now, when I look at my API, it's token. Now, I don't need documentation. I don't need to guess. I know what the completion handler gets. It gets a token. That's nice. Self-documenting code. What else we got? We got this username and a password. Now, the truth is, it is very strange to have a password without a username. That would be very, you don't really want to split these two pieces up. You want both. You want the username and the password. So what we really kind of want is a way to say in types, I would like to say and. I'd just like to put two things together with an and. Well, we can do that. It's called a struct. A struct is an and type. And I could call it a credential, right? So this authorization token or credential or the like. And I'm saying a credential is a username and a password. And that's good. In fact, your best structs will be like that. You could just read them off as this and that and the other. Now, I like to say and because I think people understand and. Okay, in English they understand. But there is a technical term. And the only reason I'm telling you this is because people on the Swift mailing lists will say it. And then you'll go, I have no idea what they're talking about. And I want you to know. Or lots of other places, if you research any other languages. These are called product types. Product means the result of multiplying is a product. And why is it called a product type? Well, how many different styles are there? If a style can have a color and a thickness, and there's 3 different colors available and 2 different thicknesses, how many possible styles are there? There are 3 times 2. There are 6 possible values. And that's why they're called product types. And you will hear people talk about these all the time. So we pull that out, and now we just take a credential. And that's pretty nice. That gets rid of a whole parameter too. But it also opens up possibilities. I got rid of some implementation details. It's no longer necessary that it be a username and password. Maybe I have other kinds of credentials. I have Facebook logins, Google logins, one-time passwords. I have all these other kinds of credentials that people could use that I don't have to change any of my code. So again, that's very nice. I'm able to pull things out. I was able to tear things apart and put them together. What else? Still has problems. We have this tuple. Maybe a token, an optional token. Maybe a token. And maybe an error. I say and, just like a struct. A tuple is a product type. It's an and type. It's just like a struct. In Swift, they're very, very close to each other. Do I mean maybe a token and maybe an error? Almost certainly no. That is not what you mean. Because 2 of these options probably make no sense. Do you mean I can have both a token and an error? Do you mean I could have neither? Well, but those can happen, right? It's not what I mean. I mean a token or an error. Well, if I want or, I don't want to use an and type. I want to use an or type. Do we have one? And yes, we do. An enum. An enum is an or type. It's how you say or. And so the most famous is result for these kinds of things. Result is the most popular name to give this, where I have a successful value or a failing error. And again, with the cases, you can read off this or that. Now, I want you to understand this is like 3 lines of code, 4 lines of code. I really mean use these like 4 lines of code. Just stick them in your program. You don't need a library. I've helped write libraries that provide this. You don't need them. It really is just like 4 lines of code. And you throw it in. You don't need to put on maps and functors, and you don't have to put a whole bunch of things on it. This is enough to get the point through. And I often create these that aren't generic. I often create little result types that are specific to my problem. Because maybe I have 3 states. Maybe I want to return that it failed, or it was delayed, or it was successful. Right? And then I would have 3. And so each one might have its own. That's all okay. Don't be afraid to just create a result type when you need it, when it's what you mean. Now, in the same way that structs are and types, and we call and types product types, when people are feeling very fancy, we call enums sum types. Sum is what you get when you add things together. And why do we call it that? Well, again, if there is one possible kind of line, and there are 3 possible types of squares, how many possible styles are there now? There's 1, 2, 3, 4. 1 plus 3. So it's a sum type. But again, it's or. OK, so what does that give me? So we've created a result. And now we can put it all in there. And what we have is we can read our whole meaning right in the signature at the point of use without any comments. We can see that login accepts a credential and will pass back to its completion handler a resulting token. Now, you do have to learn, OK, everybody means this particular enum when we say result. But once you know that, and that's why you should use that name, because that's what everybody uses, but all the information is right there. I now know this can succeed or fail. I know that the thing I get back is going to be a token. I know what I pass in. I don't need documentation. That's the lesson that I want to bring. And that's the lesson that decades of functional programming work have created for us and that we should learn from. We should break apart our complicated things into simpler things. And we should look for generic patterns in those simpler things. And then we should lift and compose those simple things into more complicated things in ways that let the compiler make whole groups of bugs impossible. I like to say break it down, build it back up. And I think both John Backus in the 70s and I think Krusty from Apple today would, agree on that. This is the information if you want to pull it down. Thank you.
Rob, thank you very much. It was amazing, and I need to say with pictures are the best. And we have a small present for you. And it's time for questions. And after that, do you remember you need to choose?
I know my job.
You need to choose the best. Yes.
Thank you so much.
So please, questions.
Thank you for your talk. I have a question. Okay, I have a question about objects. So
yes.
Often, especially when we work with a server, we get some answer from it, and it doesn't require have a full-fledged object with all the fields and just, for example, an ID. And we can get some another request and again get ID. And the only thing that server requests for us for the third query is these 2 IDs and not the full objects. I don't know I'm an Android developer actually, and in Android it's often a problem to pass an object from one activity or from one screen to other screen. Yeah, and I would like probably to work with objects like everywhere, but I have these constraints that otherwise I should have some storage and have it like in each screen and get the object by ID and all this stuff. So what do you think? What is like again the I don't know, balance, how to decide if I should still try to be object-oriented or like work with IDs sometimes?
And I think object-oriented is the wrong idea, because object-oriented here is all about adding methods to classes. That's a different...
yeah, I mean...
But what I mean, no, but I would say in the Android world, you have POJOs. And POJOs have a lot in common with structs. And so it's just data. And what I actually have liked to do, I've been working with some Android developers, is instead of doing the storage, because you can send a string, serialize it into a string and deserialize them.
Yeah, maybe.
It can be... Android has a very strange problem of handing data between screens. I agree. What I've been trying to do, and I agree, I haven't pushed hard enough to learn in the Android world whether it's efficient enough. But what I do try to do is serialize, deserialize through JSON, usually, in the same way that you would with the server. And that makes each of the screens treat the other screens like a server. And so the same ideas then can be used.
But it requires, so your models on server and your models in like database or somewhere else, they're the same. So you don't have local only fields or something like this. Otherwise you could miss them.
I do often, what I often do in those cases where they can't, where they're not, is I say it's possible to create one object from another, right? So I often in Swift, because this happens with Swift a lot, where you have codables. And the codable does need to really match what the server does, or it's a real pain. But I have there's the server version of it, and then I have my real version. I have a server user, and then I have my user. And my user has an initializer that takes a server user and pulls itself up. Yep. Instead of having lots of optionals. But part of that is because a lot of times I often find those server objects need all kinds of optionals, or in Android, lots of nullable fields. But I want my real ones inside have none. So if you hand me one that doesn't have enough fields, then I throw the whole thing away, right? Instead of having to check everywhere in the program.
Thank you.
Oh, yeah.
In your slide where you were describing about a person view,
Mm-hmm.
where you abstracted out into a person view,
Mm-hmm.
weren't you trying to step into the territories of model view, view model architecture while still talking about model view controller?
It is fine if you find a view model, or if you find a view model to be of use, because it simplifies the vagaries, or sometimes you have a mismatch between what your actual model looks like and what your view needs. This is exactly the mirror of what I just said about the server. Sometimes there's a mismatch between what you would like and what the server provides. And what I say is then you make an adapter layer that at one point I transform all into the one I want. Well, that is the same thing. I take a model and I transform it into a view model. But there's nothing special about a view model. It's just a model, right? It's just another model. It's okay to have more than one. When we said that there's a model layer, we didn't mean there's just one model object. So from the view's point of view, it doesn't care that there is some other model object out there. So I just, one thing why I push back on this sometimes is that people get the idea that I need, if I'm doing MVVM, I have to have a model. And for every model, there must be a view model. And for every view model, there is a view. And that is ridiculous. In many, many cases, it's fine not to have a view model. In some cases, it is very, very convenient, whichever is best.
I have an opportunity, so one question for me, if it's okay. Rob, what do you think about which of the modern languages, when I say language, I mean syntaxes, strength of compiler, features, is suits the idea of a strong and simple programming best?
Swift is definitely trying, and Kotlin is exactly beside it. both of them come out of this very same tradition. That's why Kotlin and Swift look so much alike. They were all reading the same notes. I have found those to be the best current for this style. There are much, much more powerful types out there that neither Swift nor Kotlin can deal with, so I don't teach them to you. Dependent types, I mean, there are very powerful types that Swift is lousy at or can't even handle. But I would definitely, especially if you want to explore how types work and how you transform one to another. And that's what mapping is, for instance. I mean, it's when you take one type and you map it one to one. You make a table of all of these are mapped to all of these of another type. Swift and Kotlin are certainly my favorites right now.
Thank you.
Hi, Rob. Thank you for this great talk. And my question is about approach with switching data sources. In this approach, where would you put logic of registering cells?
Registering the cells. Oh, that is a good question. I often use storyboards that kind of, it's not as big a thing. But I would what I typically do for that kind of thing, because the view controller is in charge, usually of knowing the table or the collection view. And so what I often do in those kinds of cases is I make each data source have a static variable, a static property that returns that information. And then you iterate over all of your data sources and say, what do I need to register for you?
Okay, so in that case, I have a problem that should know in advance, right?
But I say it has to.
Okay,
I
so
agree.
you can't plug it in just in time, right?
Yes, and I don't want to.
Okay, because you have to call all static
Absolutely.
methods.
But
Okay.
but in this case, all the logic tends to be there. I don't want it to be pluggable.
And another question about all this talk. Was it just about best practices? Because you're talking that all these things like separating responsibilities and enforcing strong typing is adjacent to functional programming. I don't think that's true. I think that's just best practices. Why is it a truth learned from others, from elders? I guess that's just a best practices. Have nothing to do with functional programming. Please correct me if I'm wrong.
No, actually, I want to amplify you.
Okay.
I want everyone to hear that. This isn't functional programming. This is things we learned because of research into functional programming. So many of these things, when you say they're best practices, the reason that they're best practices is that we've known this for decades. I often say, if we just knew as a community, as developers, if we just knew what we already knew in 1980, we would be so far ahead. We don't read our papers. We don't read the history. If you go back to the 70s, in some cases, if you go back to the 50s and read computer science papers, they are complaining about exactly the same problems that we complain about today. We haven't learned our lessons. So things like strong typing, actually type theory isn't a functional programming topic. It is because people who did programming language research mostly work in functional languages. Why? Because they like them, because they're interested. Well, and there are other nice things to study there, but it's because those are research, that's where the research happens, and that's why I encourage people to go out and learn languages like Haskell or OCaml or some of these other functional languages, not because you'll ever use them, but because they suddenly teach you things, ways of thinking that people who have thought about this a lot harder have been thinking about for a really long time. But I agree. It's just best practice. I hope it's best practice, but I don't see it that often. So
Okay, you can continue your discussion in our discussion area, and our favorite part, please.
I love that last one.
Of course, it's not a surprise. Thank you again.
Thank you.